Hello and welcome to yet another video of Cornerstones of Math. Today's problem is really easy to understand. We just want to find the maximum and minimum values of this function f theta. But this problem can be solved by two different methods, and that's what makes this problem a bit more interesting. So without further ado, let's get into it. And let us start with more interesting method in my opinion, the geometry method. Let us think about the geometrical interpretation of the given problem. The good starting point is to realize that f theta is given in the form of distance between 2 points on a coordinate plane. So let's visualize this on a coordinate plane. If we take 2 points A, which is 5, 3, and P, which is 2 cosine theta, 2 sine theta, then f theta is the distance AP. Here, P is a moving point with its position depending on the value of theta. But we can also notice that the coordinates of point P are given in a rather special manner. Can you think of a certain geometrical shape related to these expressions? Well, it is the parameterization of a point on a circle, right? P is a point on the circle which is centered at the origin and having radius of 2. Therefore, we can think of f theta as the distance between a fixed point A and an arbitrary point on this circle. And the maximization and the minimization on a circle is easy. The maximum value of distance AP is the distance between point A and the center of the circle O plus the radius R. So it is square root of 5 square plus 3 square plus 2, which is square root of 34 plus 2. And the minimum value is the distance between point A and the center of the circle O minus the radius R. So it is square root of 5 square plus 3 squared minus 2, hence square root of 34 minus 2. So we have found the maximum and minimum values. But this problem also can be solved quite easily if we just use the algebraic method. By expanding the given function, we have 25 minus 20 cosine theta plus 4 cosine square theta, then plus 9 minus 12 sine theta plus 4 sine square theta. Using cosine square theta plus sine square theta equals 1, this term plus this term gives 4. So we have 25 plus 9 plus 4, so 38. Then minus 20 cosine theta minus 12 sine theta. And we can write this as square root of 38 minus 4 times 5 cosine theta plus 3 sine theta. This is one of the very famous expressions in trigonometric optimization problems. This is the type of problem where we can apply the harmonic addition of trigonometric functions. Therefore, we have square root of 38 minus 4 times square root of 5 square plus 3 square, then cosine theta plus alpha. So we have square root of 38 minus 4 times square root of 34 times cosine theta plus alpha. Therefore, you can easily notice that the maximum and minimum values are square root of 38 plus 4 square root of 34 and square root of 38 minus 4 times square root of 34. But how are these values the same as the answers we previously obtained? Well, this is the part where the knowledge on denesting the radicals comes in handy. In order to use this formula, we must make 2 in front of the inner radical. So we write 2 here and put remaining 2 inside the radical, which must become 4. So we have the sum 34 plus 4 here, and the product 34 times 4 here. Therefore, this is equal to square root of 34 plus square root of 4 squared, which equals square root of 34 plus square root of 4, so just 2. Similarly, for the minimum value, we write minus 2 times square root of 34 times 4. So this is equal to square root of 34 minus square root of 4 squared, which gives square root of 34 minus square root of 4, so just 2. And that's all for today's video. Thank you for watching. Please don't forget to hit that like and subscribe buttons if you enjoyed this video, and I will see you in another video.